Here in this particular question, 3-point charges 1 picocoulomb each are kept at the vertices of an equilateral triangle of side 10 cm. Find the net electric field at the center of the triangle. So let me fetch the figure. So this is the figure uh, of an equilateral triangle where uh, 3 point charges 1 picocoulomb. So 1 picocoulomb, 1 picocoulomb, and 1 picocoulomb are kept at the vertices of this equilateral triangle whose side is taken as 10 cm. And the triangle itself is named as ABC, and here it is the center of the given triangle, which is the geometric center. So what it is asking, find out the net electric field at the geometric center O. So that means here in this particular case, so first of all you know that here this center, as this is the geometric center, so if you draw any you can say any line from the center of the triangle to the vertex, then it will bisect the given angle. Clear? So it will bisect the given angle. That means here in this particular case it will bisect the given angle. So this angle, if this angle is 60 degree, so this particular one will be 30 degree. Clear? So here this one also 30 degree. And similarly, if you draw any line perpendicular from the vertex, or you could draw any perpendicular from the vertex, then what will happen? So that line, and that line will definitely pass to the center, and also the second thing is that that line will bisect the opposite side. Here, so opposite side means that will divide the opposite side, that means this side, into two equal halves. And as this is a perpendicular drawn, so this angle will be how much? 90 degrees. So then this particular angle will be 60 degree. Okay, so that means here in this particular case, now if we try to draw the direction of field due to all these individual charges, and all these individual charges are positive, so here in this particular case the direction of field due to A at the centroid will be away from charge here, and similarly due to the charge at B, it will be again away from the charge. Clear? And due to charge at C, it will be away from the charge here, vertically downward direction. So that means all these charges have some electric field at the center itself. Clear? Now as the charges are equal, and distance of this geometric center from each of the vertex are also same, all the distances are same, and the charges are of equal magnitude, that means electric field at O due to A magnitude wise will be same as electric field at O due to E, that should be equal to electric field at O due to C, and that should be equal to E itself. Assume that this is E, that means each of this electric field is taken to be E here, E, and E. So as this particular angle is coming out to be 60 degrees, so vertically opposite angles are equal, so this angle will also be 60 degree, that means this whole angle will be 120 degree here. So now we can find out as three forces are acting over here at the same point, so we can solve this one by resolving, or by taking the resultant of the two fields, this field and this one. So if you can take the resultant of these two fields, which will be directed somewhat vertically upward here, this will be the resultant of these two fields. So first of all we'll try to find out what is the magnitude of the resultant. Clear? So that means here in this particular case what we can do, we can resolve the electric field into its component. So the component of this field, this particular field in the vertical direction, will be equal to E cos 60 degree. So E into cos 60 1 by 2, that will be equal to E upon 2. So that means it's one component, this electric field will be having its component along the vertical direction will be E by 2. Similarly this particular electric field due to this positive charge will be having its component along the vertical direction, that will be same as E by 2. Here same formula will be applying over here. So E by 2 and E by 2 vertically upward, so the net electric field in the vertically upward direction will be 2 E by 2 plus E by 2, and that will be equal to. Clear? So this is what we have done. We have applied the method of resolution. Here applied the method of resolution of vectors. Here we have applied the method of resolution of vectors. That means here in this particular case, also we can apply the triangle of vector addition. So if we apply the triangle of vector addition particular case, or to get the resultant value, what you can do, apply the resultant. Magnitude of resultant will be equal to under root square plus 2ab cos theta. Here angle between the given vectors will be taken as 120 degree, and each of these vectors will be equal to same, because here taking the vectors as electric field itself. So then the net electric field, magnitude of net electric field will be equal to E square plus 2 into E cos 120 degree. Root of this one, here in this particular case, how much will be getting? So it will be 2E square plus 2E square cos 120. Cos 120 is minus 1 by 2. So how much getting? 2E square minus 2 will get cancelled out, minus square of this one, so it will be root of square, so that will be equal to E. So that means the resultant of these two is has to be E itself. Okay, so finally over here, so now at the centroid, two forces we can say. One is the resultant of not two forces, the result you can say at the centroid, you can say resultant of two fields, which is E, is in the vertically upward direction, and the field due to the upper charge, which is at C, is in the vertically downward direction. Both are having same magnitude but in opposite direction. That means in this particular case we can write both the fields are same magnitude but opposite in direction, so they will cancel out each other. So that's why here in this particular case, what will be the net electric field? Net electric field will be E net will be equal to here 0 over here, they will cancel out each other.